When most people think about dangerous weather, they think about hurricanes, tornadoes, or blizzards. But in the deserts of the Southwest, one of the most impactful and often overlooked hazards can arrive as a towering wall of dust. Today on Weather Geeks, we're joined by Amber Sullins, a longtime Arizona meteorologist who has spent her career helping people navigate everything from extreme heat and monsoon storms to the massive dust storms that have become synonymous with life in the desert Southwest. We'll talk about her journey forecasting some of the country's most unique weather, and we'll take a deep dive into the development of the new PHX-Dust scale, PHX-Dust scale, a groundbreaking effort designed to classify dust storms and better communicate their impacts to the public. From the science behind the scale to the challenges of translating complex research into actionable information, we'll explore how meteorologists are working to improve awareness and resilience in the face of one of Arizona's signature weather threats. Welcome into Weather Geeks. I'm Jen Carfagno hosting today. So glad to have Amber Sullins on the show. Welcome to Weather Geeks.
Thank you so much for having me.
So I'm sure you've listened, or maybe you haven't, but the first question everybody gets on the show is, how did you become a weather geek?
How did I become a weather geek? I was always kind of fascinated with the weather as a kid, just kind of looking up at the clouds and seeing what kind of shapes. That one's an elephant, that one's a dinosaur. And then it just kind of got me curious on how they form. And that just led me down the rabbit hole of all things weather.
And now you're not just looking up at the sky, you're looking out in the distance to see what kind of clouds are forming out there, which we'll get to talking about dust storms in Arizona. But you've spent a lot of time in the Southwest. You spent your career basically out there. So what drew you to the Southwest, to the unique challenges really that come with weather out there?
Yeah, I was born and raised here in Phoenix, so this is home for me. And so I've pretty much spent my entire life in the desert Southwest. I lived in Phoenix and Tucson and El Paso, Texas, and all of these spots have the monsoon season that happens from June through the end of September. So this is kind of my wheelhouse. It's the stuff I grew up knowing, and it's the stuff that I've been forecasting professionally my entire career.
Yeah. Let me go through Amber's career. She is chief meteorologist at ABC 15 in Arizona since September 2009, involved in the AMS, or American Meteorological Society, as a station scientist committee member and board member of the Central Arizona chapter, vice chairman of the University of Arizona Hydrology and Atmospheric Science Department Board, Climate Central's Climate Matters Program Advisory Committee member, and her Bachelor's of Science focused in atmospheric sciences and meteorology is from the University of Arizona. So a lot of Southwest experience.
Yeah.
And of course, as you said, you sort of grew up with this, but even if you haven't, everyone knows that Arizona is famous for their heat, the thunderstorms they get in the summertime that can bring such dramatic weather, the flash flooding, and the dust storms. As you kind of started in your career and then continued into it, which type of weather surprised and frustrated you the most, just from a meteorology and forecasting standpoint?
The monsoon in general is frustrating to forecast because it's not like we're forecasting cold fronts coming in and can say, okay, we're timing this frontal boundary and the rain is going to be here between 3 and 5. We just have to sit there and watch the radar. And sometimes the storms are popping up in the mountains and they move right in, and other times they don't. And they're right on the doorstep and nothing happens. And it's crickets. And everyone's like, what is going on? And they'll rain themselves out over the higher terrain and then not move in. And then, of course, we're tracking a lot of outflow winds from those storms too. And so if the storms themselves don't make it in, we're trying to identify these outflow boundaries on the radar and see, when are these going to collide with each other? When are they going to collide with our mountain ranges to get that air to rise and get new storms to form? And sometimes that's really frustrating too, because you'll watch the radar and you'll see all the boundaries coming in and think, oh, this is it. And then they collide and nothing happens. So it's endlessly frustrating to try to time out monsoon storms. And dust storms in particular get really challenging once the sun sets, because then we start to lose some of the visuals that we have to kind of forecast and identify them. Outflow boundaries aren't as clear on the radar oftentimes after the sun sets. And so, sometimes you can't even see these things coming in, and then all of a sudden it's there.
And I have to imagine when it comes to forecasting dust storms, there's other factors besides the weather itself. It's the ground conditions, how dry it's been, if there was any rain there recently, if there's any wildfires in the area, that all has to be a factor, right?
Yeah, soil moisture is huge. And, like the biggest dust storm we ever had in the city of Phoenix happened on June 5th, 2011. And if you look at what happened in the years leading up to that, in the area just south of the Phoenix metro, it's primarily ag land down there across Pinal County, which is just south of Phoenix, or it was at that time. And, the 2009, 2010, as we went into recession, a lot of that land went fallow. And so that set us up for really monster dust events with, just a ton of land that was dry and dusty and just ready to form giant dust storms. So it really matters what's happening south of Phoenix as to how bad the dust storms in Phoenix will be.
It's really fascinating, actually, that link between the economic times and the dust storm. And I had never really made that connection before. It kind of takes me back to the Dust Bowl in the
Right.
30s.
Same idea. And so now we're thinking, okay, well, what's going to happen in the future in Arizona? Because the Colorado River is in crisis. And all of that Colorado River water that flows down, a lot of it gets pumped through a canal system that takes it through central Arizona and down into Pinal County to water the farmland and ag land down there. And they've already had to take significant cuts to the water supply in Pinal County because of what's happening on the Colorado River. And we know that the Colorado River, the forecasts are not good for that river system in the years ahead. And there's probably going to be more cuts to the Central Arizona Project water that these farmers are able to tap into. And so that worries me as well, because if we have more land that goes fallow, we're going to get back into that situation where we get some really intense dust storms.
Right. And again, that's another side effect of the lack of water from the Colorado River system that I think people don't think about. They think
Yeah.
about the farming impact, no doubt, and very important. But there's these side effects which could impact an even greater population on an instantaneous basis, like with visibility, but also think about air quality and the issues that come with it too, and that kind of longer lasting impacts. So
Yeah, and the air
it's huge, the
quality thing is it's
ramifications.
huge. Yeah, the air quality thing is no joke because we have fungal spores in our dust. And those fungal spores, when they get kicked up in dust storms, if they get into your lungs, they can cause valley fever. And valley fever can keep people sick for months, if not years, and cause other health impacts. We profiled a kid who came to study at ASU, and he contracted valley fever because he was out in a dust storm. And within weeks, he had a stroke. And he's still in the hospital. He's been in the hospital for over a year. And that's an extreme case. But, valley fever is a really big threat here in the desert Southwest during our dusty times.
That's really scary. And I think a lot of people don't realize that certainly outside of your area, is that a risk that is commonly known, just the risk of dust storms in general, and also the side effects that can come and last for a while from within your area? Are people aware of these risks?
Yeah, people that have lived in Arizona for a long time certainly have, but we have a lot of new folks here that have moved in the last decade or so to Arizona, and so it is coming as quite a surprise. All of these other risks that they don't think about when a storm is out, and so that's kind of part of my job and part of the job of my team is to educate people on everything that the monsoon could bring. And that's why we do a yearly monsoon special and we talk about these things. We're not just talking about rain and lightning and all the fun stuff that people look forward to. We're letting them know, there are other significant threats like the dust, like valley fever, like dry lightning that can spark wildfires, which leads to burn scars and flash flooding. So there's a lot of challenges during the monsoon season and in the years and weeks leading up to the monsoon season each year.
Dust storms primarily a monsoon season issue, but they can occur year round, right? I mean, what is sort of the challenge in even forecasting and then also getting the word out when people aren't expecting them?
Right. So they can occur year round. I think we do see some differences in dust that gets picked up in the winter versus dust that gets picked up in the summer. If we have, a fall storm system coming through from California with a cold front attached to it, we may see some winds pick up with that, but it tends to be pretty widespread and dispersed, just general dusty conditions. Whereas the dust storms that we see during the monsoon season are those towering haboobs that are caused by convective outflows from thunderstorms. And so those are kind of the ones that make headlines, and that all the images you see shared online are of those kind of convective dust storms.
We think of the Southwest when we think of dust storms and vice versa, but they happened in other places. There was one in early May in central Illinois, of all places.
Yeah.
And of course, Texas, New Mexico, which is part of the Southwest, but it's not just an Arizona problem. Do dust storms in other parts of the country and around the world carry the same health risks?
I would say definitely the particulate matter is going to be a problem in your lungs no matter what. I'm not sure if those same fungal spores that live in our Southwest soil are found elsewhere across the United States, but in general, it's just not a good idea to be breathing in any kind of particulate matter if you can avoid it. That goes for smoke or dust or anything else.
Right. So of course we want to try to avoid these when they happen, to communicate the risk when they're going to happen, and of course communicate when they're actually happening. How is the general public alerted to a potential incoming dust storm? Well, one that could happen and then one that's in progress.
So usually in the morning, if the National Weather Service here locally sees that there's a high risk of a dust storm, they'll put out a blowing dust advisory, kind of a preemptive, hey, from these hours, watch out for blowing dust. And then, of course, all of the television stations are covering that as well. So we're trying to get the message out on TV, on social media. When we start to see the dust pick up, then we're wall to wall coverage online and on streaming and on ABC 15 to let people know. And we have a chopper that we send out to try to give us a bird's eye view. That's how we're also able to kind of estimate the height on these things, which can sometimes be over 5,000 feet high. And so we're doing everything we can. ADOT, the Arizona Department of Transportation, set up years ago a network of cameras and sensors to try to give us a better idea of what is happening south of the valley. Because again, these things are forming mainly over open land, unpopulated or very low populated areas. And then they're just picking up dust for miles and miles and miles before they move into Phoenix. So the challenge has been to be able to see what's happening in those more rural areas before the dust gets close to Phoenix. So again, setting up cameras for that, setting up dust sensors for that. If we see outflow boundaries showing up on the radar saying, get the chopper up, we want to get an image of this to see if it's something or if it's, nothing. So all of those things, but it is definitely a challenge to try to get an idea of what's happening in places where there are not a lot of people to help tell that story.
Right. The observations are so key.
Yeah.
I forget my ignorance here, but is there a short fuse warning that goes off like on your phone when there's a dust storm
Yeah, so
warning in
if
place?
it reaches a level of a quarter mile visibility or less, then a dust storm warning is issued. And then you'll get those those emergency alerts sent directly to your phone. But again, it has to be a quarter mile or less visibility with that. And not all of our dust storms reach that criteria.
Yeah, that makes sense. That makes sense. All right, we're going to take a quick break. We come back, want to talk about a scale that you have started with a group of people started to help identify the strength of dust storms, which could really help with the communication. So we'll be right back. Welcome back to Weather Geeks. Jen Carfagno hosting today, talking with Amber Sullins about dust storms and life forecasting in the desert Southwest. And Amber, we left off talking about when you might get a dust storm warning, that it's got to be a pretty intense situation. What what other criteria are there to describe the most intense dust storm? What makes it so intense?
Visibility is a big one, but that's kind of hard to quantify because it's so variable within the storm. But visibility, wind speeds, if the winds are gusting over 25, 30 miles per hour, that's one of our more intense dust storms because sometimes the dust just comes in and winds aren't too bad. It just is getting dusty all around you. So that's another thing. And then how big is it? How tall is it? How wide is it? How long does it last? All of these things.
Right. And so this is all information that you can describe after it's in progress.
Yeah, exactly.
And
It's an after the fact kind of a thing.
right. And it happens and everybody's talking about it and they want to know how bad was it. So tell me more about the scale that you and a fantastic group of other scientists came together to create. And I just love the collaboration that was involved here. So just some of the names on the list are, people from across the scientific enterprise.
Yeah, and that's probably, I think, the best thing about this new scale is the collaboration across all sectors. So we had a professor at Arizona State University kind of spearhead this, named Randy Cerveny, and he got everyone together. We're talking folks from the flood control district, folks from local utility services, folks from air quality departments. These are all the top meteorologists in the Phoenix area in every sector imaginable. And we all came together and talked about how we could get this done, how we could develop a scale for dust storms that would be similar to the enhanced Fujita scale for tornadoes so that we could better inform the public, but so that we can also have better record keeping about how bad these dust storms were. And so that's what we looked at. And it was challenging because a lot of people would say visibility would be the number one factor. How bad was it? Brownout conditions, or could you still see a mile down the road? But we found that that was particularly challenging to try to get data on. So what we came up with is there is actually a network of air quality sensors across the Phoenix metro area. And we were able to tap into those sensors to get readings on dust concentrations. So we developed this scale based on dust concentrations. It's a 1 to 5, 1 being the lowest dust concentration, which would be about 1,000 micrograms per cubic meter of particulate matter. And then the highest end, a 5 on the scale, is about 5,000 micrograms per cubic meter. So that's how we were able to scientifically quantify this and be able to, again, have a network in place that is not going to change. So we're not kind of chasing the standard here. We know that this is going to be the baseline, and then we have subcategories that determine, was this widespread or localized? Was it a high wind dust storm? And was it long duration, over 3 hours, or short duration?
Yeah, you need it to be objective. It cannot be opinion. It cannot be based on personal observations. It has to be based
Yeah.
on data that you can routinely get after, which is a challenge with scales. Everybody wants a scale for everything. I think it helps the general public. We know what 1 to 10 looks like. We know what 1 to 5 looks like, 5 being the worst, 10 being the worst. And so it is extremely helpful. But getting to that point is a lot of work. And you guys have done some great work in trying to assess the data available and the information that could help characterize this the best. That benchmark storm that you talked about in 2011, what did you go back and historically assess that? What would you call
Yeah.
that?
It was the worst. It was the worst on record. It was a 5. Originally, before this paper went through peer review, we actually had the scale at 1 to 6 because of how bad that one was. It was like way worse than the other 5s. But, after it went through peer review and we, were forced to kind of simplify it a little bit more for communication, for better communication to the public, which I completely agree with. But that was still the worst on record. I mean, this thing was enormous. It stretched the entire length of the Phoenix metro area. So we're talking like over 50 miles wide. And it was over 5,000 feet tall. At least that was the estimate that was given from our chopper crew that day. And that is another point of challenge is that, the heights on these, that's a really hard thing to measure too. So really it's just, get the chopper crew up, and based on, where they're flying, they can give us an estimate as to how tall they think this is. But that's another challenge to try to quantify it. But that one was incredibly dense as well. And it was because of those land use issues that we talked about earlier, and all of that dust primed and ready to go. I mean, it turned day into night in a matter of seconds. It was just the ugliest dust storm you've ever seen. And the dust lingered. You woke up the next morning and you still thought you were in a dust storm. Like, that's how bad it was, because we didn't have a whole lot of rain to follow it.
Right. Wild. Absolutely wild. Dust storms are crazy and quite scary. I mean, they're incredibly dangerous for driving, which is another part of this we haven't really tackled yet. But warning about incoming dust storms isn't just about a health concern. It's incredibly dangerous on the roads.
Yeah, it really is. And so ADOT, our Arizona Department of Transportation, they put out messaging, pull aside, stay alive. And they want drivers to pull off to the right as far as they can, put the car in park, turn your lights off, take your foot off the brake, and just wait there. And I get a lot of questions about that every year, because people want to just leave their hazards on, and they think that that's probably the better thing to do. But what we've seen, and why ADOT has chose this messaging, is that the visibility in a dust storm is highly variable. And so it's not just, oh, you're in the worst of it now, it's getting better, it's getting better, it's going to keep getting better. You could be in a situation where it's getting better, oh no, it's worse again. The visibility is back down to zero. So the thought is, you don't want to have your hazards on, because as that visibility maybe slightly improves momentarily, you're looking for someone to follow. You're like, oh, this is the way out. Oh, those folks have their hazards on, I'll go that way. And then the visibility drops again down to zero, and now you've crashed into them.
Mhm.
So the idea is to get off the road to the right as far as you can, and just kind of make yourself invisible, which may be counterintuitive for some of us. But, there's all of this is tricky. And we just kind of need to heed the warnings and the expert advice, and just, not think that we know better, because we've seen a lot of bad situations where people get run into from behind when that happens.
When a dust storm is developing, how quickly can you assess the strength of it, either officially based on the scale or just sort of anecdotally now based on the scale? Like this looks like this might be a category 4 dust storm. How
Yeah, so
quickly
we
can you do
tried
that?
that. I kind of debuted this last summer during the monsoon, and what I found is you cannot really estimate the category based on what you're seeing visually. Because visually, you'll see something that's, 4 to 5,000 feet tall, super wide. You're like, oh, this thing is a beast. But you can't really tell what's happening inside that wall of dust. And the way we had to devise the dust scale is based on air quality, and that's what's happening inside. And so it may not be as dense inside as it looks when you're looking at the big picture. So we had a dust storm last summer, when we were kind of trying out this scale, and it really looked to me like it would be a 4 or a 5. It looked bad. It was really tall, really wide. Well, we got into the data once it moved into the valley, and it was only a category 2 on the scale, because the density of that dust, the concentration of the dust inside, was really not bad once it hit those air quality monitors in Phoenix. Um,
Interesting. So does that mean if you were caught inside of that, the health impacts would not be as bad, and the visibility in terms of your if you're driving, what you would be experiencing wouldn't be as bad?
yeah, the visibility certainly wouldn't be as
Yeah.
bad, because dust is more dispersed. It's less
Yeah.
dense. So again, it's hard to identify. The other catch with this is that the dust storm may be a Cat 2 when it gets into Phoenix, but it might have been far worse over those open desert areas in Pinal County. And we don't have air quality monitors down there to capture that. So the thing with developing this scale is we had to find the best data available, and where that left us was air quality monitors in the Phoenix metro area. And what is the dust scale severity once it got to us?
Right. Gosh, this is quite interesting
Data.
and complicated.
Yeah.
Is it
Yeah.
transferable to other parts of the country, considering you need the specific data?
Yeah, I think it's a good framework for other places to see what would work for them. Obviously, the air quality monitors that we have across the country, it's not a nationwide network. It's all done locally. And so you can take what we've done here in Phoenix and you could see if you have available data to kind of mimic it in other areas, or you can see what is available to you, kind of piece apart our study to see what would work in your area. But unfortunately, because of the complexity of all of this and the available data, this scale for now is just specific to the Phoenix metro area.
We'll take a quick break there. Come back. I want to talk a little bit more about what other types of weather this kind of thinking might apply to. Welcome back to Weather Geeks. Jen Carfagno hosting today, talking with Amber Sullins about dust storms in the Southwest and a new scale that her and other stakeholders have developed to help communicate how bad a dust storm was. And was is the key word, because you do it in retrospect, kind of like we do with the Fujita scale, the enhanced Fujita scale. And you brought that up actually as a comparison. I was thinking that with the enhanced Fujita scale, it's sometimes difficult to put one EF1, EF2, EF3 label on a tornado because it changes intensity. Like you described dust storms as well, they change intensity throughout their lifetime. What do you do in the case where a dust storm changes intensity?
The intensity may change before it gets to Phoenix. And then once it gets to Phoenix, we look at the monitors all across the valley and kind of, see where it was at its worst. So what's the highest concentration that any of these monitors picked up? And then that would help drive the dust scale and where it ranks.
And
Because
then
they do change intensity. Sorry to interrupt, but they do change intensity across the valley, because once you get into Phoenix, you have no more dust to pick up. You're just dropping dust. So essentially, most of these dust storms, as they come in, they're most intense in the southeast portions of the Phoenix metro, because that's where they're arriving. And then as they work their way across downtown Phoenix and into the northwest suburbs, they get less dense.
That's interesting. This is really fascinating, all of it. This is something as meteorologists we know about, but you know it with such intricate detail. And obviously, it's so very important to the people in Arizona and other places too that deal with dust storms. So you guys are delving into this, I think, in a really useful way. But one more kind of side question along with the lines of, if you're assessing it after the fact, what if it never went over sensors are there sensors everywhere? I guess we see this with tornadoes, where a tornado, or a strong one, might not hit something with that could cause enough damage that would allow it to get a high enough rating on the EF scale to really represent how strong it was. Could the same thing happen with dust storms on this scale?
Well, we have enough sensors spread across the Phoenix metro area that any big dust event is going to hit at least one or two of those. So that was one of the reasons why the air quality monitor sensors were the thing that we ultimately settled on, because the network is vast and we can tap into that. So I don't think that's going to be a problem in Phoenix. Now, if this dust scale gets expanded, it certainly will be a problem, because as I mentioned, in Pinal County, south of Phoenix, we don't have this kind of data that's being collected. And so that's why, dust storms may be far worse down there. We'll never know. All we can really do is get a visual from Chopper. And then once they come into Phoenix, then we can start measuring what those air quality concentrations are.
How do people get the scale? You talked about showing it on air. For you, is it on social media? And what about the other stakeholders? How do they share it?
So we've worked together with ASU to develop a website for this. So it's phoenixdust.asu.edu. And so as soon as the air quality data is collected and analyzed, there will be updates on that website as to what category that dust storm was. So everyone that's open to the public, it's not just those of us that worked on the project, everyone can see what the scale is. And then in my newscast on ABC 15 and on my social media channels, we'll be sharing that information as well.
It's so exciting and so interesting. And I just love the evolution of better communication. It's hard to make big strides in communication, but this is a huge one. It's also hard to create a scale that gets accepted in a broad way. How has that process been, especially because you are working with a large group of stakeholders?
Yeah. Well, it's been years in the making, but thankfully everybody worked very well together and we got it done. And of course, it went through the peer review process. And so there were some things, as I mentioned earlier, that we had to change. And ultimately, I think we got it at a really good place by the time that this was published in the Bulletin of the American Meteorological Society.
And that's where I saw it
Yeah.
last November, December. So is there like a stamp of approval that says this is an official scale, and what exactly specifically is it called?
It is called the PHX-Dust scale, PHX. Originally, we were going to call it P-Dust because, that's got a nice ring to it. But then we figured we need to explain what the P stood for. So PHX-Dust scale. And yeah, that's what we're going with, 1 to 5.
Yeah.
And it's launching officially, hard launch this summer.
It's official, the
Yeah.
PHX-Dust scale. I love it. Have you considered, or has anyone approached you with taking the sort of the process of developing this scale and applying it to other weather types like flooding and flash flooding in particular?
Not yet, but that's fascinating. Tell me more about what you're thinking there.
Well, just, you could just go back to Texas last year with the flooding down on the Guadalupe River. Every time there's a big flood event, it's so difficult to communicate how bad it's going to be. There's these big flash flood warnings, which are smaller than flood watches, but still they're county wide most of the time. And most of the people in the county don't necessarily experience flash flooding. And so I'm always thinking about there's got to be a better way to describe the impacts that you are going to have specifically. It ends up becoming very much local driven by whether it's streams and creeks or terrain or previous conditions, storm drains, the rainfall rate. There's so many different factors, but I don't have specific ideas, but I definitely feel like flooding is like the next big topic that we need
Yeah.
to address to make warnings more effective.
Maybe it's more like stream and river gauges and how far above flood stage they're expected to get. Maybe there's some kind of ranking there.
And then, a lot of times it becomes really urban flooding or, city street flooding that people get stranded in. Like, wait, I didn't know it was going to happen, but you were under a flash flood warning. But that, so many people ignore flash flood warnings. So,
And it's really challenging
yeah.
because each city has, different drainage infrastructure. And the
Yes.
same amount of rain here in Phoenix doesn't do far as much flood damage as it would in Tucson, for example, just because that's the way the city's set up.
Yeah. Yeah. It would be interesting on a small scale in a city like Phoenix, though, because you do get flash flood
Yeah.
risks, or maybe even start in Tucson because they have that higher risk.
Yeah.
And to
Well, we had some flood
yeah.
control people working on the dust scale, so I'll let them know.
Yeah, float it by.
What
I'm interested. Keep me
they're
posted on that because
what
it's
to do.
definitely a topic I want to chase after in the
Yeah.
future. Well, this
It
is
sounds like
great.
it's
I
useful.
appreciate your time today, Amber. This
Of
is
course.
fantastic work. What's next for you? Anything after the dust storm? Or are you going to let this settle, as they say? No, we got a quick freeze up. Oh no,
Are you still there? If no,
you back?
okay, I'm back.
I said, are you just going to let the dust settle, or is there anything coming down the pipe next?
We're gonna let the dust settle. This should be a very active monsoon, so we need to see how
Yeah.
this is all going to play out. But we're gearing up for some active months for monsoon season. And then, of course, the impending El Nino is probably going to mean wetter conditions into the fall and winter across Arizona. So we're going to be busy. And of course, we need that rain because the drought is still pretty bad across the Southwest.
The last time we had a stronger El Nino, that was Tropical Storm Hillary. I was in, where did I go? Palm Springs. So I wasn't in Arizona, but ended up in Palm Springs with, tropical moisture. So get ready for more of those kind of things this year.
That tropical moisture gets caught up in our monsoon flow. Those storms, sometimes the remnants will come in, but they don't even have to. If they're down near the Baja and the winds are just right, we get tropical moisture beefing up our monsoon moisture, and we get some of the heaviest rain events on record in Phoenix and across Arizona. So
you're right.
yeah,
Buckle up for this season.
Exactly.
All right, well, that's it for Weather Geeks. Amber, Sullins, thank you so much for joining us. And to everyone who is listening today, that's it for this episode of Weather Geeks, where we spotlight the minds behind the models, the chasers behind the storms, and the passion behind the forecast. Thanks for listening. I'm Jen Carfagno. We'll talk to you next time.